we'll be mainly talking about few internal utilities which are used mostly by the system programmers. And moreover, like while we are designing any compiler, assembler, or any kind of translator, you have to always really worry about such kind, or you have to kind of justice for what is expected to be done on the front. So let us say, for example, suppose if I have this code, correct, and yeah, so we gave call to ABC, correct. This is my code. You can see, if we recall, we talked about that code earlier. So second thing, this is another program that we wrote where a call to ABC was given, correct, and we saw there is a call to PQR, correct, and 3.c. So while we discussed about instruction pointer, how it changes that time, if you recall, or even to talk about stack aspect, how stacks are internally used by the system. At that time, if you recall, I introduced this one and we created an executable, and then we executed that code in a debugging mode, correct, which helped us to find out how the stacks are, how the stack internal is used. And if you recall, in the yesterday's session, or rather previous session, I showed you the process address space, okay, where there is a space given for the stack area. Okay, that would be per process stack is created. So when I say per process, I mean to say per executable, because your executable program in memory is called as process. That's what I think you must have heard about definition of a process. Now that process can contain many things, correct? Like for example, suppose if I save and if I come out, so let us combine this 1.c, 2.c and 3.c dash M32. Okay, now let me see if I can minimize this. Okay, from this angle, probably yes. Okay, let me take another window. So I will search here. Okay, sorry, here ps-ejh grep bash. So we have two bash services. Okay, one is for this, another one is for here. Correct. Now when I execute this code, now I wrote this ps-ejh grep bash. So if I remove this, for example, and if I write less, try to find out where is bash. Yeah, so this is the current terminal that we are referring to, 100152, where this bash is running and we're executing this ps command. Now you will see that on this bash, which is the process at with 97131, correct, there is nothing like I mean to say there is no other service running. Now when I write, say for example, ./a.out, I executed that code. Even if I say, for example, execute this, I will never get any child over here. Now suppose if I say cat greater than a, now it is waiting for my input, correct? Because it is expecting that I will input something which could be written in the file A. So if I write now this, you will identify that within that bash, this is a child created cat, correct? Now, like when these processes are running, how do I know what state they are into? In what state the process is into? So that it would be helpful for us rather to really understand, like uh, when your processes are getting executed, what happens at that end? What happens at that end? So let us try to address that part. So now let me write this. So now the states that your process can be into can be seen here. So let me go there. Yeah, these are the process states. Can you see that? Now we recall in bachelor's, probably you have been taught operating system, and in that course, rather, in that course, there were there was a diagram called process state diagram, and we were told there are only 5 states that your program can be into. But actually, when you go at Linux level or an operating system level, one can see that we have these different states. Correct. So if I write ps-s, now let us see. You can see that these are the states that are there for the services that are running now. S plus R plus. Now, when we executed this ps-s, when that program, now whatever the output that we saw here as an output of ps command, it was actually because we executed ps command in memory, output was displayed and program was terminated. So that's the reason why you see R plus. There is S plus, SS, and so on. Correct. So like if I see about this cat, it is sleeping mode. Now suppose I try giving some inputs. Okay, now I cannot execute both the things at a time. You can see that cat position remained there, but it is in S plus mode only. Now I cannot see at the same time like what output would be, because it needs to execute this ps-s command from the other terminal. Now when I go pass the control to other terminal, ultimately what will happen? This current process will go into sleep mode, and that's what this S plus means. So when your two programs are communicating together, okay, what happens there? How much time this cat actually is running? Do we know that? Can we know that statistics? How much time that program is in memory? So if I say control D, okay, control D. Now if I go here and if I write this, now cat is gone. I cannot see cat. Correct. Now the PS command, I can see that as R plus. Now two bash are running. This is the current bash that I can see. It is yes, and this bash is in sleep mode. So that's why SS plus. So if I have to see what is the meaning of those symbols, yeah, see, plus is in the foreground process. Okay, so whenever you write, and small s is the session leader. Who is the leader at point of time? Correct. So PS is not the leader because PS executed the code and it was terminated from memory. So back. Suppose if I translate this code gcc-m32.c, we executed the code. Now if I see the current status of PS, only these things are correct. Now if I write this a dot out, now it is waiting for my input. Now if I go here, you can see that it is in yes. Still the leader at this terminal, the other terminal, the leader is its bash command. This one, S. That's why this SS is. Even still here, it is R plus because this executed the code of PS with dash S, which was shown as an output to us like this, and it got terminated. So when it displayed this output, it was in running mode. Now when it gets terminated, nothing would be shown. Now if I press Control Z here, that means let me send this in background. Right, I sent it in background. Let us see what is the state of a dot out. What is the state of a dot out? Now it is changed to T. Can you see this?
Yes.
Okay. Now let us try to see what is this T means to us. What is T? Stopped by job control signal. That's what we said. Na? Control Z. We pressed here Control Z. That's why you can see my program was stopped. It says stopped. Somebody terminated it. Now if I press Control D, and if I now see output here with same command. Now what exactly it stopped? We don't know. If I press Control D again, my terminal got deleted. So ultimately, everything which was along there got terminated. So this bash and this a.out was completely gone from memory. I got find them. So probably if I try to say like this, only one bash, correct? A.out. Nothing is there in memory, correct? Because it got terminated. Are you with me? So I hope you must have understood now what is process state and how exactly we do see the process states changing. So you can try all other options rather by seeing the operating system. You can call as like the channel link that I shared earlier. Okay. So that can be used for reference purpose to understand what exactly happens when we do say executing a process or executing a program and how program is converted to process. Okay, now let us go back to our code. We were talking about that a.out, correct, which was created for 1.c, 2.c, 3.c and 4.c. Now what to do? So first of all, if I see, we saw those 4 codes, well, like 1.c referring to a function written in 2.c, 2.c refers to a function which is written in 3.c. Now definitely we can see that your program execution environment will spend some amount of time rather in 2.c and 3.c. Now how to find out that? So there is a utility called GNU Profiler, so which I showed that day. Showed, I mean to say, the man page. So it displays the call graph. Now this profiling is one of the important stage in software programming or any kind of, when I say programming, I mean to say that part. Now through this profiling, we definitely can determine various parts of program code which are time consuming and needs to be rewritten. If at all you see that some part of code is wasting time, because of it only your time complexity is creating a problem, then you can definitely get idea about such a stuff. And this will help, this utility will help you to write program in well manner so that execution will be very fast. And that's what generally a desired goal of every programmer. Now it may not work with the kind of programs that we wrote, but whenever we are talking about very large projects, like for example, when I asked you, can you download C code, or let me show you, like I have Postgres source code with me. So okay, let me show it through probably. Yes. Yeah, this is my source code of Postgres 14.3. So like if I see the properties, see how many files are there. Nearly 7,900 files. Size of it is 142.2 MB. Okay, let me open this. Let me open this. So it contains multiple directories, and this is the source code written by written for the Postgres service. Now I hope those like I assume like you must have used MySQL or PostgreSQL in your bachelor's probably, or some of you must have used MS SQL Server or Oracle too. Now, how many of them are open source? Probably we can say MySQL and Postgres are probably the two open source largely used. Now, even MySQL was moved further and they came up with something called as MariaDB. Correct. Now, if I try to see source code of it, say for example, if I go to this SRC directory and if I take this backend. Okay, now let me take commands. Now let me use this alter.c. Let us open this file. So for all alter commands, generic alter commands that are there, this is the source code which is supposed to be executed in background. Now see how the code is written. Now when you are writing very big code like the way that is shown to you in front now through number of files to be nearly 700 and size to be nearly 140 MB. When it gets executed, if because of some process, your program speed is getting hampered, execution speed is getting hampered, performance is getting degraded. How to handle such scenarios, how to work with these scenarios. Correct. And this utility will be helping you on that front. So that's why I said whenever you are talking about very large projects, this profiler can help you. Generally, it is said like it will save your day by not only determining like part of your code which are slower in execution than what was expected, but also it will help you to find many other statistics which many potential errors, bugs can be spotted and you definitely can sort out them. Again, how to use this? Simple. Okay, so we have to enable the profiler first and then execute the code and done. So say for example, we have written the code. Okay, and we have created like we had that star.c suppose, and if I say less 1.c, okay, q q less 2.c, q less 3.c are your code statements. Now what you have to do is create an executable for each of them. Each of them I mean to say as a through the linker, because they are referring to functions written inside. So assuming you got some errors. Now after you create an executable, so we have to add now few more things while you really link this code. So now you can take screenshot while I'm writing this. Correct. So dash w all, correct, dash pg, correct. Now your program name 1.c, 2.c, 3.c, correct. And now your executable name, suppose my exe. Instead of a.out, suppose you want your executable name, you can write it. Otherwise, it will generate a.out. Note that I have used this option called dash pg. Now this dash pg is responsible to generate extra code to write profile information, which would be suitable for analysis of our analysis program called gprof, which we are going to make use of. So you have to use this particular option dash pg. So if I go and check for man gprof, see the profiler data is taken from the CalGraph profile file, which is created by a program that are compiled with dash pg option of C compiler and so on. Let us not talk about other ones. This dash pg option also with links versions of the library routines that are compiled for profiling. Correct. And Okay, let us execute this. So we got few things. So are there errors? So one can see there is an error, correct? Variable I, and so on. So if I see less 1.c, main is there, less 2.c, ABC is there, and let's 3.c. We got this. Now, what are the command that we wrote? Actually, okay, I wrote this frequently. Okay, let me not write this. Only simply you have to write this. Okay, GCC-M32 W all dash PG and so on. So if you do this, then no errors because there is no error because it was written twice. Like if I write GCC 1 dot C, say same program name double two times rather, it means two definition. It treats them as different two files. So if I now see after execution of this command in the background bottom, you can see that your executable got created. Now you have to execute that file. Now I wrote ls-ltr, so sort in that order. So latest created file would be appearing last as the last element. Fine. Now simply write say dot slash a dot out. So let us write dot slash a dot out. So when we wrote this, what happened? Our program got executed. Correct. But if I try to see now ls-ltr, can we see something happened there? Correct. Can we see something happened there? Yes. I think nothing happened because probably have we made any error there above? Let us try to check. So we wrote w all dash pg, your executable name and program name. Suppose if I write dash pg 1.c 2.c 3.c dash o my exe. Okay, we got this. Nextly, let us write ls, sorry, ls-ltr. So we can see your executable got created. Now execute my exe. Correct. Now, if I see ls, sorry, can you see gmon.out file? Can you see that gmon.out file towards the bottom? Bashir, Roshan, can you
Yes,
see
sir.
gmon a.out, gmon.out file? Now, this file is generated in current working directory where you executed the code. So earlier what I did was I made a mistake by writing this dash pg after that 1.c, 2.c, 3.c. So I have to write it before the code execution like this. So this is the command. So when I fire this, okay, let me remove a.out and my exe. Let us remove gmon file as well. So we don't have anything now. We have latest file added was forward c. So let us execute this command. So if I see ls-ltr, nothing is there. So your executable is there. So when you execute this file, okay, your executable would be executable. You executed. Now we fire at ls-ltr again. You can see that file generated. Am I right? Now you have to make use of gprof tool. How to use this? So you write gprof. Sorry. Now, if you recall, like what is the executable name that we gave? MyExe. Am I right? What is analysis report dot txt? Now, if I see, can you see analysis report dot txt?
Yes.
Correct. Now let us try to see what exactly it contains. So let's. It starts with saying this is a flat profile. Correct. Flat profile. Each sample counts as something written. No time accumulated. The cumulative type and self, everything was written. ABC, PQR. Correct. Then percent time, the percentage of total running time of the program used by the function. Cumulative seconds, running sum of the number of seconds accounted for this, and so on. So it added a few things. Let me go further. I can see this statistics now. Qual graph. Okay, qual graph is shown. What qual graph displays? This is actually a qual tree, or generally called as qual tree. In some context of it, like it says qual graph, explanation follows. We can see that it says this table describes the qual tree of program and was sorted by total amount of time spent in each function and its children. Now our machine was too fast. Too fast. So we said ABC was called main was calling ABC, APVC was calling PQR. Now when it went to ABC, it is a child. So ABC it's calls PQR. Correct. Now you can create some scenario like this. Now I'm giving you task for today because I can see that only 16 students are there. So this task you are going to submit, I will give you 10 marks right now before I finish my class. You have to write simple program like the way that I wrote 1.c, 2.c, 3.c, 4.c, whatever, 4-5 files. OK, try to give call to functions in each other. Yes. Maybe it's not like that 1.c call 2.c, 2.c call 3.c and so on. I mean to say you call anyway, only one of the files should contain main. Now when you wish to compile that code, I want you to do this. Write this one. This kind of statement. OK, when it is done, you have to write this. OK, and then I want you now right now to submit this file so that as you are there, so you can get benefit of attending the class today. OK, I will deduct marks of others. OK, start now. Understood what is to be done? You write any simple C code. Make sure that you don't copy anybody because I'm going to see right away. OK, and I want you to submit it on Moodle. Don't tell me that you don't have laptop. If your laptop is not working, I don't care. I want that to be submitted before my class ends. Fine. Try doing it. I'm adding that. So if you have any questions, you can ask me right away. Any question? No, correct. So you understood it.
For which file you have to submit?
So you can write any code, C code. I mean to say. This is the first statement and this is the second statement that you have to execute. And I want that like in between this, like this is the one which you executed. Then you execute this, your exe. OK, and then you execute this profile. OK. So GCC dot slash a dot sorry dot GCC dot slash my exe. Okay, and I want you to write this. You can take screenshot of this. I want you to create it for your files. I don't want you to take 1.c, 2.c. You can give same names, but you have to write your own code. Give function name as your name, your first name as one function, your second name as second name. I want to say middle name, your father's name, your brother name, your sister name. These are your function names. I want you to submit right now. You have like nearly it is 6:34. So you have 20 minutes to write that code. Simply add some statements in the code the way that I have added there in my code. Correct. I'm adding an activity on Moodle and you are going to submit this. And I'm going to give high weightage to this particular part. Fine. So start.
Sir, which file we have to upload?
I'm adding that. You start writing now the 1.c, 2.c and all things. So I'm using some names there on Moodle. So don't worry about this. This is a sample example that I'm demonstrating there. You can use your own code names for the function. As I gave the names as your family member names should be there. So I'll be accepting only submissions which are done in next 20 minutes. And so I will show you what I have added there. So let me okay, can you see this one? In continuous evaluation, I have added this classwork. Okay, so this is so let me display this. Yeah. So create 4 files containing C code. Say 1.c contains main and calls function ASD defined in 2.c. ASD in 2.c calls a function PQR written in 3.c and PQR written in 3.c calls function DFG in 4.c. You can assume any kind of order in giving call to functions written in 2.c, 3.c, 4.c. You can give any number of calls even. It's not only one call. There can be any number of calls. You can add more calls. Make sure that you give more than one call across a function across these files. Right? So you have to submit, like I have added, I want what is to be submitted. Execute command for GNU Profiler and add all 4 C programs along with the analysis report generated using gprof command. So totally 5 files should be there. And I'm going to execute the same thing on my laptop too, depending upon what you submit. Okay, so start. So I hope you are having access to Moodle. You can use Moodle and work out. So you all would be getting benefit of this. The rest of the people who are not attending the class will get marks mostly out of 40 because they are so inconsistent. Okay? Yeah, start. If you have any question, you can unmute and ask me the question.
Sir, can you check if it is correct?
Yeah, somebody said so, like I could not hear. Who was there?
Sir, I have submitted. Can you check if it is correct?
I want to know who you are. Sorry, can you please tell?
Sir, Tushar.
तुषार. ओके. अरे तुझा दिसत नाही व्हिडिओ. हा ठीक आहे. हे तू एकाच फंक्शनला कॉल दिला रे 3-4 वेळेस. तू काय कर, आवाज येतोय माझा?
हो सर.
तू जे XYZ PQR ला कॉल दिलंस ना, ते वेगवेगळे कॉल असतील ना. म्हणजे PQR ला तू 2.c मध्ये पण देशील, 3.c मध्ये पण देशील, अशा टाईपचं. म्हणजे त्याच तिथंच न देता दुसऱ्या फाईलमध्ये. एकच फंक्शन 3 वेळेस कॉल करायपेक्षा ते वेगवेगळे नावं टाका असं म्हणतो. तुझ्या फाईल
हा
किती
सर.
टोटल?
4.
4 आहे ना. हा ठीक आहे, कर तसं चेंज आणि त्याला चेंज कर, त्या फाईल डिलीट करून. तुला त्याच्यात दिसेल कॉल किती वेळेस होता. Okay, now what will happen is, like when you open that file, probably your own file, when the report gets generated, you will be seeing how many times some function was given call and how exactly that thing happened. So if it is process consume, like time consuming, then you will realize what exactly happens. त्याच्या तीनच फाईल का दिसतात तिथं? PQR XYZ फंक्शन्स, दोनच फंक्शन्स होते का ते?
हा सर, एका फाईल मध्ये एक फंक्शन.
मग त्या तिसऱ्या फंक्शनला नाही कॉल दिला तू, चौथ्या फाईल मधला? ते पण
करतो.
बघ घेशील. ठीक आहे, ठीक आहे. चला, गुड. ऍटलीस्ट गुड ट्राय. त्याला रिप्लेस केलं तरी चालेल तुषार तू. हा, ज्ञानेश, आवाज ऐकू येतोय? अनम्यूट करून बोलू शकतोस तू. तुझा आवाज नाहीत बाळा. ओके, तू काय केलंय, एक एकच कॉल दिला. See, what you have to take care is like I want you to give mixed calls. Like the way I showed you, it was like 1.c is calling 2.c, 2.c is calling 3.c. Why not have 4.c and 3.c call in 2.c only? 3.c will have calls to 2.c and 3.c. Because see, we are not executing anything there, na? So it should be displayed only. Try to see like what happens if at all we execute that function. Now then you will realize what exactly I mean by time consuming. Correct? Try doing that. I can see only 2 of you tried submitting it, but it's okay. Like I want you to bit faster. So I can see you helped others as well. Some of you invited others too who joined now. But anyway, I'm not going to consider their inputs or their submissions. Yeah. Try to do it very fast. I can see only 2 of you submitted yet.
Can you increase time little bit?
Hmm?
10 minutes. 10 minutes time.
Okay. Okay, good. Thank you. Tushar, I can see you submitted, resubmitted it. So can you see something strange in the report? You can take multiple function definitions later as well. Like if at all you want to try this, multiple submission, multiple functions written in one file and they are called in some sense that way.
हॅलो सर.
हम्म.
सर टाइम थोडा पाहिजे होता जास्त 5 मिनिट.
इथे छोटे छोटे कोडल्या काय वेळ लागतो तुला? का रे? कुठे गेला तू?
सर
तर थोडा बाय छोट्या छोट्या लाईनला लिहायला काय लागतंय? कोणी मित्रमैत्रीण आहे का त्याला वेळ लागतं असं? ठीक आहे, तशी मी अटेंडन्स आय हॅव डाउनलोडेड द अटेंडन्स लिस्ट, सो नॉट टू मच वरी अबाउट. You are using what, Vishal? Mac OS? Vishal, which OS you are using? I don't know what version you installed there.
I am
Sir,
also
the
facing.
commands aren't working in my.
Sorry,
Sir, the commands aren't working.
what is the problem?
Not.
Okay, so you can come tomorrow and show the errors to me in the afternoon, those who are facing this error. Vishal, Seher, correct? Fine. So I will keep it open for you to submit later because you pointed out the problem to me.
Could it be because I'm using a different version?
Sorry?
Could it be with that I'm using a different version of
Like,
Ubuntu?
if you have updated version of Ubuntu, then there should not be any issue at all.
Basically, I'm not using the virtual machine. I'm using it on Windows.
You are using on Windows.
Yeah.
Then do you think you will understand what I tried telling? You might not have, brother. Most of the things I don't think you executed everything what I showed the classes. Okay, I have extended the time for you peoples rather till 7:15. You can submit that till 7:15, and those who are facing errors can come tomorrow and discuss with me in the class. Okay, probably after 3 o'clock in the department. I'll be there. Then I'm closing down the session. Okay. Let us meet now in next session. So where we'll be talking about make utility. Okay. See you then. Thank you very much.